Many crinoid fossils in the Paleozoic were found with a hat accompanying them. Platyceratid snails are often found entombed atop the calyxes of many crinoids, from the Ordovician period all the way to the Permian. Many theories have been put forth to explain this occurrence. One of the earliest ones is that these crinoids were predating on the snails. Later, it's better understood that it is the snails that are the ones seeking out the crinoids due to their coprophagous diet. Yes, they are likely to have feasted on the crinoids' excrement, even living their entire lives without ever leaving the crinoid, since some of them have shell apertures that seems to grow into a tight fit with the shape of the crinoid calyx. So it's thought that this was a commensal or even beneficial symbiosis. The hat snails were simply janitors eating away at the crinoid's waste. However, some studies have come out that suggest a less mutual arrangement between the two. When analyzing the average sizes of the Crinoid Corocrinus, it's found that those with platyceratids on them are generally smaller in size, indicating that they had trouble getting enough nutrient in life. Other crinoids were even found with boreholes that were likely made by these snails on the side of their calyxes, which suggests that these platyceratids would have some kind of proboscis to reach into these boreholes. The snails were not just eating their waste, but stealing undigested food or even their gonads. The long tubes seen on these hole-ridden crinoids might have been a defense mechanism to deter these snails from attaching to them to begin with, which the snail simply bypasses by drilling straight through it. This drilling is more likely to be parasitic than predatory in nature, as specimens have been found with multiple healed boreholes. And if this was a one-time act of predation, it would have been rare to see this behavior fossilized, but instead, fossils of them are so abundant, which means that these snails stayed with their living host throughout their life. A lot of crinoid species have adapted to have increased spinosity, and it's speculated that this too might be a response to the snails, as the targeting hypothesis suggests that the snails are sometimes targeted by other predatory animals, and as a result, their crinoid hosts too get damaged in the attack, leading to their need for spines. Snails such as those in the genus Spiniplatyceras have spiky shells themselves that further corroborate this hypothesis. Crinoids also show signs of regeneration, like split tubes, regrown smaller arms, or regenerated spines, showing that they have recovered from past attacks. One crinoid, Arthroacantha, takes it even further by having articulating spines pepper throughout its calyx, which can move independently and were probably used to reduce the amount of organisms trying to attach on it. Their rivalry seems to last up until the Permian, where the Great Dying wiped out the last of the platyceratids. Crinoids would go on to survive to our modern times, where they can now live free from their unwanted snail neighbors. Right?